Hi folks, my name is Timna Denwood, it's just been said, and I'm just going into the final year of my PhD at the University of Manchester. As the title suggests, I'll be presenting my recent research on how the use of alternative interfaces might help to improve representation in participatory GIS. So this research considers ways in which the map interface might be designed in a way that better supports both the researcher in the question they're asking and the participant in the answers that they are giving. So first, I'll give you a little background information on the specific research gap that I'm focusing on before presenting a case study I used to examine the argument and the results produced, of course, including some nice little maps. So it's pretty well established that the use of local knowledge can add value to the decision-making process, and participatory GIS is widely deployed for this purpose. It's used as a means for collecting local views and opinions on a broad range of topics, from land right disputes to mapping areas of religious belief and conflict. But this research focuses in particular on the siting of new infrastructure in a rural community. So whilst the use of local knowledge can reveal details that are previously unknown to decision makers, and make local people feel more included in the decision-making process, the means to collect this valuable data are often lacking. So this research looks in particular at the challenge of representation. So by this I mean how real-world features are presented on a map. This is particularly tricky with participatory GIS rather than just conventional GIS, as sort of the complex ways in which people interact with and experience the world around them often aren't particularly precise or straightforward to map. People don't tend to refer to precise boundaries in their environment or have detailed and specific knowledge of the geographical world around them. Instead, sort of using notions of place and connecting emotions and experience to spatial entities. As it stands, there is a persistent over-reliance on primitive spatial units that are too often selected for their familiarity to the researcher and for ease of analysis. So I mean like kind of points and simple polygons. And they're chosen for their familiarity rather than their suitability for representing sort of the nuanced information that participants might wish to impart. So this is problematic, as for the participant, this can limit their ability to elucidate sort of spatial thoughts and feelings, and for the researcher, it can serve to influence the definition of the very question being asked in the first place. It's what GISRUK's own Johnny Huck coined the hammer of participatory GIS, which refers back to the analogy of Maslow's hammer, which is that if the only tool you have is a hammer, you'll treat everything as if it's a nail. So this sort of highlights the over-reliance on a small number of familiar tools and techniques being used, instead of ensuring that the participant and not the system dictates the nature of representation used. Although the challenge with representation in participatory GIS is frequently mentioned in literature, little is done about actually developing and using alternatives. So this work poses a bit of a step change, encouraging researchers to create new tools rather than just accepting the limitations of what is readily available. This research explores the possibilities that arise from the use of alternative spatial units using two case studies in the Outer Hebrides. The first uses viewsheds rather than simple points to enable participants to make informed decisions about undesirable locations for a new wind turbine. The second uses least cost paths rather than simple lines, so that users can map realistic routes to contribute to the design of a new network of footpaths and pavements in a way that can then reflect the terrain and other obstacles. So both of these interfaces, I've lost my point now. Both of these interfaces are intended to empower participants, produce data sets that are not only better suited to the questions that they're being asked, but also better suited to the answers that they wish to give. And as a result, provide richer data sets. So to answer these two sort of socio-spatial questions, two bespoke online participatory GIS interfaces were created. These were hosted together at barramapper.co.uk. Data were collected at 3 workshops during November 2019 in the 3 main settlements on the Isles. Whilst full instructions were provided on the website, sort of being there in person as a facilitator enabled participants to have each task explained individually if needed, and ask questions if they were unsure throughout the workshop, kind of at any point, as well as to encourage discussion about the needs of the Isles and get a bit of feedback on the methods. At each stage of the workshop as well, participants were asked to add free text to accompany their mapping contributions, so that these could be analysed simultaneously with sort of the geometric data collected. So, a bit of background on Barra. The Isles of Barra and Battersea are the most westerly inhabited isles in Great Britain, and have a combined area of around 70 kilometres squared and population of about 1,300. The interior geography of Barra and Battersea, which are 2 islands joined by a really short causeway, consists of Mackay, I'm probably pronouncing it wrong, apologies if anyone's Scottish, these are just low-lying grassy plains essentially, and uninhabited hills and lochs, with the population sort of mainly living in hamlets and crofts along the coast, which is so beautiful. Huge kind of white sand beaches and super blue seas, sharks and everything. There's definitely worse places to do field work. Anyways, this location offers sort of a unique opportunity to explore the use of alternative spatial units in participatory GIS, as the residents have recently produced a local energy plan in order to assess existing and future energy needs. So this has opened up plentiful opportunities to obtain local views on issues that are currently being faced by the Isles. The plan identifies electricity production and active transport specifically as 2 of the key areas of concern. This is largely due to the super remote location of the Isles. So because of where they are, the current energy infrastructure is very limited, with just one mains electricity connection to the grid, and oil being shipped in from mainland Scotland, which makes it very expensive for local residents. As well as limited energy infrastructure, there's just one single track primary road which circumnavigates the Isle of Barra, as you can see on the map, and an almost total absence of footpaths and pavements. So the transport systems on the Isles are sort of overwhelmed and inadequate, which is also compounded every summer by really high levels of cycle tourism since the opening of the Hebridean Way cycle trail, which just follows on the main road on the island. So adding a local renewable energy source, such as a wind turbine, coupled with a new network of footpaths to open up movement across the Isles and pavements along roadsides, has the potential to alleviate the pressure on the system and address some of the issues raised in the local energy plan. Whilst there is clearly a demand for new infrastructure, so the lack of existing industrial landscapes on the Isles means that the impact of any new developments will be high. This sort of coupled with a reliance on tourism that's brought about by the prevalence of natural beauty, the community input is really vital when it comes to planning to ensure that satisfactory solutions and plans can be identified. So the first interface uses Viewsheds as a spatial unit. These are calculated and drawn in real time when the participant clicked on the map. The screenshot of the interface here in fact shows 3 viewsheds, as participants were able to add as many as they wish to the same map, creating a composite of viewsheds, which then delineate the areas a turbine could not be placed. Participants were asked to indicate where they would not wish to see a turbine, as this is something that they would have a greater awareness of and could be reasonably expected to answer, rather than asking where they would want to see a turbine, which would require more sort of specific knowledge. So as such, the viewshed indicates everywhere a turbine would be visible to the participant if they were to stand on the click location. In this way, both the participant and the decision maker gain a more comprehensive view of the kind of expected visual impact of a wind turbine without increasing the level of effort or technical skill required. The use of viewsheds as an alternative spatial unit, sort of together with a reframed question, means that the participant is better empowered to provide meaningful answers. So in this case, participants are given considerably more straightforward task of entering known point locations which denote places to shield from view, such as homes or particularly nice views, as opposed to being asked to accurately assess point locations where turbines would be invisible from those places. So from the perspective of a researcher, the data set produced provides a meaningful insight into the participants' views and variations on sort of visual acceptability of a wind turbine development, as opposed to a collection of somewhat arbitrary points indicating kind of understandably ill-informed opinions on where a wind turbine should or should not go. The second map interface asked participants to draw on a new map where they would like to see footpaths and pavements sort of created or restored on the aisles. Instead of using nodes or click locations connected by straight line segments, as you might in a dot-to-dot drawing, the nodes are connected using least cost paths. So these are calculated and drawn again in real time in the browser using a version of the A-star algorithm and a digital elevation model for the underlying data set. So instead of relying on the participants' sort of individual ability to digitize a set of straight line segments, the onus for data quality is placed on the algorithm and data set. In order to balance speed and accuracy, a resolution of 35 meters was used in this instance for the DEM. This could easily be replaced with a different data set if you wanted to explore a different question where elevation didn't have an impact. In this instance, the least cost paths follow the easiest route to walk, whilst also avoiding impassable objects such as water and sharp drops, so they don't just disappear into the sea, enabling participants to draw more complex and realistic routes without any additional skill being required. As you can see in the screenshot, the participant could add multiple nodes to ensure that the route followed their desired path. If, for instance, the algorithm was to take them a different route, the participant need only click undo to remove the last node, and then they can add a few more in between sort of the start and end locations to produce the route they preferred. So there are two fundamental issues with using lines normally in participatory GIS. Just to go into a little more detail to explain the last kind of interface a bit. And these have led to lines almost never being used in participatory research. So firstly, in order to draw precise lines between points on a map with a cursor using a conventional kind of dot-to-dot straight line segments, it requires like a really high level of skill and so much time volunteered on the part of the participant, which might be hard to come by. Secondly, the use of sort of simple digitized lines can also present challenges for the researcher with regard to aggregating and actually making sense of the data collected. So, for example, if multiple participants are trying to plot the same route between 2 points, it's highly unlikely they'll draw the exact same route, even if they intended to do so. One participant might just draw a straight line segment between 2 locations, sort of, A to B, whereas another might spend a lot more time doing a far more detailed path. There's no way of knowing whether they both meant the same route, just had different time available or a different level of skill, or they drew the routes exactly as they desired, both being intentionally different. So this challenge arises from the varying levels of generalization, both between lines that have been digitized by different users and between multiple lines that have been digitized by the same user, as you can sort of see in the figure. So on to the results. Over 3 workshops, there were 22 participants, which is around 2.3% of the eligible population. Participants contributed 18 viewsheds and 100 footpaths. They were predominantly over 50 years of age, with just over half identifying as female. So here we have the results from the Viewshed tool. One sec. Excuse me. Over multiple viewsheds and users, an inverse suitability surface was generated. So with the areas containing the fewest viewsheds, or none at all, being the most acceptable to participants, and those with the most being the least acceptable. So the dark pink areas, therefore, are where multiple viewsheds are overlaid, such as towards the south of the Isles on Battersea, and this indicates areas that people would least like to see a wind turbine. The areas that remain grey don't necessarily show where residents would be happy to see a wind turbine, but instead where they don't have strong views to the negative. As well as the viewsheds, written feedback left by participants in the comments with each submission showed a variety of reasons for the specific locations, as can be expected, as well as feedback on the tool itself. The reason that some participants gave for not submitting any viewsheds was that in fact they would happily have a new turbine anywhere on the Isles if it meant that they could have better access to green energy. So it's sort of the opposite of NIMBYism. They still, however, tested the tool and provided feedback, indicating that it was straightforward to use. One participant in particular, very conveniently for my research, initially clicked the area around their home as an area that they would prefer not to have a turbine. But then on seeing sort of the larger area, this would also prevent from having a turbine as shown by the viewshed, because it's produced in real time, then retracted their input, saying that in fact they didn't think it'd be able to be seen for so far and would rather have the energy as the visual impact is worth it. So this specifically indicates the benefit of having the viewshed over a point-based tool, as the user is able to make an educated decision based on the impact rather than just clicking with no contextual information. So whilst there aren't a great number of viewsheds submitted, they hold much more valuable data. So moving on to the second case study, this map presents the complete raw data set produced using the A-star algorithm tool, with the darker lines indicating where a greater number of participants the same paths to be located. A total of 107 new routes were added by the 22 participants, along with written feedback on the tool, saying it was straightforward, usability, and useful. The addition of the orange heat map highlights areas that receive particularly high interest from participants, so the greatest number of click locations. These include areas that might be expected, such as the main settlements, but also a particularly picturesque beach along the north coast. This final map then presents the cleaned network of footpaths and pavements produced by the residents on the Isles. So this is sort of removing loops and duplicates and closing up circles. So the darker routes are those intended to be pavements, i.e. concrete and raised along roads, which again was indicated in the comments. And the lighter green indicates footpaths, so cleared routes without any raised concrete. The responses mainly fell into two categories: pavements for safety, or footpaths for opening up the centre of the Isles and restoring heritage routes that had been sort of forgotten. So not only was the ease of use indicated by a number of participants stating this in their feedback, but it's also clear sort of from the number of routes drawn by each participant, which is directly in contrast to previous line-based participatory GIS research, which kind of highlights the importance of developing new interfaces to ensure that they are suitable for the question being asked. This proposed network would mean an increase of approximately 400% on the current network length, with the addition of 192 kilometres of new footpaths drawn and 43 kilometres of new pavements, which would cover 100% of the primary roads. So results from these two case studies suggest that the development of new alternative interfaces and the use of more considered spatial units has the potential to improve representation in participatory GIS. Accordingly, these findings might contribute to developments in the field that could improve democratization in decision making by adding value to the participatory data through enabling both the questions to be more representative of the aims of the researcher, and the answers to be more representative of opinions of the participant. So ultimately, my research kind of seeks to encourage the creation of new spatial interfaces, abandoning sort of once and for all the hammer of participatory GIS in order to obtain more effective data sets that better support sort of socio-spatial decisions. Thank you very much for listening this morning. I know I flew through that rather quickly. If you have any questions, I will do my best to answer them now. Otherwise, please feel free to bob me an email on the address below.
Great. Thanks, Timna, for a really interesting talk. So withhold your applauses if you can, and please ask questions in the chat. So we already have a couple of questions, more coming. A question from Pyri. Thank you, good research. So that's great. Did your participants accept the use of the technology easily?
Yes, so it was sort of quite an older crowd that came along. That's kind of based on the demographic of the Isles anyway, so it has a slightly older population than the rest of Scotland. And everybody managed to use it okay. You know, whilst I say that, you know, there were instructions on the website, people definitely appreciated having them explained and me being there if they came into troubles. But it's a really simple, straightforward tool to use. So it didn't present too many problems. Sort of the next part of my research is actually looking at sort of doing a paper-based version in a way of kind of improving accessibility and asking the same questions. So it'll be interesting to see kind of when that's done, kind of how it contrasts to the online version. I'm hoping to get some of the same participants to do both parts of it and get feedback that way as well.
Yeah, and in that kind of evaluation, you also hope that people would prefer the web version. Otherwise, it makes the whole thing slightly problematic. It happened to me in a project that actually some people prefer the paper map, and it's like, all right, yeah. It makes sense.
It comes along with like an auto digitization thing, and it's all very fancy. So, but yeah, no, and they also then the kind of the paper one. So hopefully I'll be talking about this at next year's GISRUK.
Yeah.
But
so many more, sorry to interrupt, many more questions coming. So the next one is from Phil. Given the influence you might have on the results from participants regarding the viewsheds, did you use a digital surface model which includes buildings, vegetation, etc.?
So no, basically it's just the only thing that it takes into account is water is blocked out and the coast and steep slopes. Buildings and vegetation don't really come into it. It's a very sort of on the surface thing. Yeah. Basically.
Yeah, so second half of the question, also, have you considered modeling the distance decay rather than a Boolean output? For example, a wind turbine further away might be visible, but has a lower visual impact.
I didn't know, but it's a really interesting point. Thank you. Oh, I should be taking notes from these.
Yeah, you can actually copy paste the content of the chat if you want.
That'd be a really good discussion point. Thank you.
Yeah. So next question from Robin Wilson. Could you say something about how these were implemented technically? What web mapping framework did you use? Did you use other web-based tools for things like the A-star algorithm, or did you implement it yourself? And did you find performance issues with doing the processing in the browser? And he's also asking whether the tools you're developing will be open sourced or not.
So the tools were all written sort of kind of between me and Johnny, my supervisor, and I believe on his GitHub. I could be wrong. Please do correct me, Johnny. He's in here somewhere. And yeah, the processing in the browser was a bit tricky. So that's why. So there's the data elevation model of 35 meters was used. We did try others, but it was just too slow. With the Viewsheds, you know, it would take a few seconds for it to appear. sorry, not the Viewsheds, for the route mapping. So I think we tried 10 or 15 meter resolution to get sort of more precise lines and routes, but it was just a bit too slow in the browser. But sort of for the scale of the island as well, it provides like a really nice compact area to do the research in. So 35 meters was all right in that respect, but that was sort of the place where doing it in the browser had the impact. And it's just a balance really between precision and speed. Has to be a trade-off somewhere, I suppose.
Yeah, there are more questions, so it's really like a grilling. So, how did you? So this question is from Nick Behrman. How did you pitch the feasibility of actually creating these footpaths, pavement, wind turbine? Is there budget for this? How do we avoid residents being involved in this? Then there being no budget to create these and people becoming disenfranchised.
So this is something I've been really, really aware of throughout the project, and in the workshops as well. People were already, so residents of Yars were already disgruntled, some of them about other projects where they'd had their views taken and then frequently completely ignored. So as a sample, it was already quite disenfranchised. But my research was sort of developed and came about with the community energy company who made the local energy plan on the island. And I'm staying in contact with them. We'll be going back up again, sort of present back these results. The aim of the plan was to kind of hopefully enact some of the ideas in it. So I would like to hope that they could be used. In terms of kind of budgets and things, I'm not sure, but it will all be fed back to the community energy company. So hopefully can actually be put towards some use, and they will certainly be fed back and communicated with the residents of the Isles, hopefully in person when that's feasible again.
Let's see if we manage to do the last two questions. Next one from Robert Berry. Low resolution digital elevation models can significantly overestimate zones of theoretical visibility. Were participants made aware of this and the limitations of the approach? And this is a difficult concept to communicate to non-experts. An interesting and more inclusive approach, but could be criticized as a black box solution if the way it works is not properly understood by users.
Yeah, so it's granted slightly clunky, but I think being able to be there in person whilst the kind of residents were doing the tasks meant that there was the opportunity to explain a lot, and a lot did ask. So as an island, they're very aware of viewsheds and things like this. So it's quite I don't know, as a population, they already have quite a good idea about this kind of research, and they already have one wind turbine on the island. So also kind of have the physical example there. So with a few, yeah, I did discuss kind of the limitations of it, and that is more, my research is more on the side of kind of the theoretical argument than necessarily the precision of a tool, and it's more about kind of trialing alternative options to just using a simple point. So even though the Viewsheds might not be, super precise, especially taking into account kind of buildings and vegetation and things like that, they're still giving the user more information than just dropping a point or a little marker on a map would do. Yeah.
Great. So we actually have, at this point, we can do the last question in the last 30 seconds. So Kathleen Hafferty, does this approach have potential for capturing participant views throughout the planning and implementation process? And for example, the temporal element capturing the changing public opinion that is particularly important for wind and renewable energy development.
Yeah, absolutely. So It just uses a Firebase database, so you could create a new one at various stages and compare the results as the project goes along, and collect the same data repeatedly along. Of course, it's just it's freely available on a website, and people could do it in their homes as well. It doesn't necessarily need to be in a workshop. So yeah, absolutely, it'd be great to get that, sort of the temporal differences as well as things progress. And it could then also be refined further and further with like actual plans and other factors, sort of as the sites of specific scientific interest and things like that could be taken into consideration as well. So yeah, that's a good point.